Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken and his at University of Albany and his brother Joel Chaiken. We're here to help you learn how to approach SAT math questions. So here is a wow. They even tell you what type of question it is. It is a system of equations, and my computer thing has frozen. Yeah, system of equations. That's cool. Okay, so. What is about? They only want you to know what y is. So there may be like a fancy way to do this. Maybe we should just do the Seth said. Maybe
No. It's glaring you in the face, and our listeners should be aware of what to do.
Okay.
You want to find y.
Right.
It's a system of two equations and two unknowns.
Right.
Please learn that a general approach to multiple equations and multiple unknowns, one general approach is to one by one eliminate the unknowns until you get one equation and one unknown, solve for that unknown, and then back substitute to find the other unknowns.
Right.
Now, they are interested only in the y unknown and not the x unknown.
That's right.
So that says use elimination and eliminate x.
Right. That's what I was just going
to say. And then when you solve for y, you could put your answer in and move on to the next question.
Right.
Okay. You do not need to solve for x.
Right.
Okay.
So
should we do it?
Yeah. So if you
it says x equals four times quantity y plus 1. X appears once in the top equation, so you simply take the value for x given from here, you substitute it for x in here, and what you get is 4 times the quantity y plus 1 divided by y equals 6. Which is one equation in one unknown, and one way to solve it is to just try out the answers and see which one makes it true, or you could use the cookbook method of solving. You bring y to the other side, which is okay as long as y is not 0. You get obviously a linear equation. You could simplify the arithmetic by canceling out a 2, and then you get 2y plus 2 equals 3y. Subtract 2y from both sides, and you get 2 equals y, which is answer A.
Oh, that's really good. Yeah. I really like the way...
And then it's a good idea to check it. Put the 2 into the y and see if it's 6. So we have y is 2, y plus 1 is 3. That's good. 3 divides 6. That's great. Put the y in the denominator. We get a 2. The 2 goes into the 4, leaving a 2. Y plus 1 again is 3. So 2 times 3 equals 6. It checks. Move on to the next question.
I don't think anyone is really going to check.
Will they? I don't know. Again, do the survey. I haven't done a survey.
I haven't done a survey either. So, Seth, so the way I would have done it very similarly, I would have solved for x. I would have said x was 6y, and then I would have thrown the x here. And I would have done 4 y plus 1 is equal to 6y.
Yeah. Well, I just gave into the temptation. They told me what y is right in the nose, so why take a step to solve for y? Oh, sorry. They told us x right on the nose. Why bother solving for x there?
That's right.
One more step.
That's right, but first you have to see that.
Yeah, well, you see it. You have to learn to see it. There's an x here. They say solve for y. Well, where's the y and where's the x? There's a y and an x in the first equation. Y is in the denominator, so you have to. That's something to be a little bit afraid of.
Yeah.
And then the bottom, y is on one side, x is on the other side, and it tells you explicitly x equals.
Right.
So my judgment there is that it takes fewer steps, fewer chances to make a mistake.
Right.
If you use the equation as it is and eliminate x by replacing the value given directly
Right.
by the left-hand side into the one y that appears
right.
in the top equation. And the only thing you get is a fraction, but then you could worry about that later. You say, well, is it possible? Need we be concerned if y equals 0? No, it's clear. If y equals 0, the numerator is non-zero. It doesn't make any sense.
Right.
Y equals 0 cannot be a solution.
Right.
So whatever solution it has, it's non-zero. You multiply by whatever the solution is and get a condition on what the solution must be, which uniquely determines the solution.
That's a lot of talking, but that's right. That's right. Let me just make a comment that first of all, you have to be a little more observant to do what Seth did. I would say, again, we don't have the ability to do this live. It would be great to do these things live and ask people what they do. But it just, following one's nose, it just feels like it would be very natural to solve it and set it this way and do it the way I did it. Plus, this equation looks more friendly than the one Seth has. Seth is all obscured, but the one Seth
So what do you have, 4? You might be right.
Seth,
you might be right.
Finish.
Okay.
Seth, please.
Yeah. Yeah, there's a point to that.
Can I please finish? Yeah. Yes. So all I'm saying is that if you do it the purple way, which is the way I'm following, but the computer board froze, the equations look more natural and more familiar to everyone, okay? And therefore, you feel calmer, you feel more relaxed, you know?
Oh.
Yeah. It is a psychological component to this. We're sitting here as big shots doing one question. I can do almost any one question on the SAT sitting here. You try to put yourself in position of taking it like I did, and your brain gets fried. So it's totally fine to have a formula. See, so the way Seth, let me write it out again. Which equation just looks more naturally easy to solve? This one or this one? You know, for basically people who are not PhDs in math, right? This one. And, you know, many people will just, do 4y plus 4 is equal to 6y. Yeah, and then subtract the 4y. And you get 4 is equal to 2y, then you get the answer. Right?
Yeah.
So you have to,
I guess either way I could work. Yeah, I could see is you're transforming the top equation, into a linear equation.
Right.
Yeah,
right.
So, yeah.
Then you have to do you have to remember that you have to do the cross multiply.
Another advantage of Joel's method is that if you bring you transform x over y to x equals 6y, you have an x equals at the bottom, you have an x equals, and so you could just write these two are equal. Which again is another sequence to eliminate y.
Right.
Sorry, to eliminate x, and you get a genuine linear equation.
Right.
You just have to make sure to when you simplify it, to distribute the multiply 4 over both the y and the 1.
Yeah, absolutely.
If you absolutely.
So basically we're done. But just like yesterday, let's do an experiment. What happens if you don't distribute? I'm just really curious. You would do...
Then you get 6y equals 4y plus 1.
4y
wrong. This is wrong.
1. 4y... No, I want to see if that's a distractor. If 4y plus 1 equals 6y, you subtract 6y, you subtract 6y... No, 4y. You subtract 4y. 1 is equal to 2y. Wow, so it's not even a
Oh,
distractor. Look at that. They
yeah.
should have put that
Why? Because
in.
that
They
leads you to y is a half.
they should have put that in as a distractor.
Yeah.
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 Yeah. Okay. Okay. I think
We
that's
did
it,
it.
right? Yeah, we did this. Okay,
Yeah.
everyone. Thanks for watching. Please like us, dislike us, give
Yeah.
us comments, and send us emails with more SAT math questions you want us to
Yeah.
do. Okay, everyone. Okay, we're done, right?
Okay, we're done.
Okay, see you tomorrow. Bye.
Bye bye.